Ennemcien, we have seen what is polarization of light. Rather, what is plane polarized light. Now we want to study how can you produce or generate plane polarized light. There are 4 processes by which you can convert ordinary light into plane polarized light. One is by reflection. 2 by double refraction. 3 by dichroism. 4 by scattering. So these are the basic processes by which you can convert ordinary light into plane polarized light. By reflection, by double refraction, by dichroism, by scattering. We will discuss the first one first and mention the other to some extent. That's all. When you if ordinary light, when you allow ordinary light to fall on the surface of a transparent material such as water, glass, etc., a fraction of it will be reflected. The other part will be transmitted by the material as it is transparent. The reflected light is found to be partially plane polarized. That is, when light is reflected by the surface of a transparent material, a fraction of the reflected light is found to be plane polarized. And for every transparent material, there is a definite angle of incidence for which the reflected light is 100% plane polarized. That angle of incidence is known as Brewster's angle or polarizing angle. For example, if you allow a beam of unpolarized light to fall on the surface, on water surface, at 53 degree angle of incidence, 100% of the reflected light will be plane polarized. That means 53 degrees is the polarizing angle or Brewster's angle of water. For glass, it is about 58 degree. So for each transparent material, there is a definite value for this polarizing angle. See this figure. This is ordinary light, which contains vibrations in all possible planes. Theta p is the polarizing angle for this transparent material. Then this reflected light is 100% plane polarized, vibrations of which are perpendicular to this plane of the paper. Now we define this plane, that is this plane containing the incident ray and the normal. This plane is called plane of incidence. So the vibrations in the reflected light or plane of vibrations in the reflected light are perpendicular to the plane of incidence. A plane perpendicular to the plane of vibration is called plane of polarization. I have said it earlier. So here the plane of polarization is the plane of incidence, because vibrations are like this, perpendicular to the plane of the paper or plane of incidence. That means plane of polarization is the plane of incidence. So we will say that when light is incident on this material, transparent material, at its polarizing angle, the reflected light is 100% plane polarized in the plane of incidence. That is the scientific statement. The transmitted light or refracted light will also be plane polarized in the perpendicular plane. Here the vibration, refracted light contains vibrations parallel to the plane of incidence. So these two plane polarized beams are called orthogonal beams, polarization forms. That means vibrations in these two beams are mutually perpendicular. Here vibrations are like this, here vibrations are this, like this. So such two plane polarized beams are called orthogonal, mutually perpendicular, orthogonal forms of polarized light. Now there is a simple law connecting this angle of polarization and the refractive index of this material. That is called Brewster's law. Tangent of Brewster's angle or tangent of polarizing angle is equal to refractive index of the material. That is, tan theta p is equal to mu, where mu is the absolute refractive index of the material. This is not Brewster's law, this is the deduction of Brewster's law. We will see the actual Brewster's law shortly. But in almost every textbook, tan theta p equals mu is stated as the Brewster's law. I'm not going to correct it. That's only a deduction. Now, at Brewster's angle of incidence, the incident light and refracted light are mutually perpendicular. That's a special case. When light is incident at Brewster's angle or polarizing angle, the reflected light and the transmitted light will be mutually perpendicular. Actually, this is Brewster's law. And tan theta p equals mu is only a deduction of this law. That is derived from this law. See, we can prove it. You can use Snell's law. Here, angle of incidence is theta p. So this angle is also theta p. This is the angle of refraction, say r. This is alpha. We want to prove that alpha equals 90 degree. Now you can use Snell's law of refraction. It is sin I by sin r equals mu. That is sin, here I is theta p, I equals theta p, so sin theta p by sin r equals mu. That is equation 1. But tan theta p equals mu, Brewster's law. Tan theta p is sin theta p by cos theta p. That is equal to mu. Equation number 2. You can equate these two equations, these two sides. Then you get sin r equals cos theta p. Sin r is cos 90 minus r equals cos theta p. That means 90 minus r equals theta p. Or r equals 90 minus theta p. Let it be equation 3. Now from this figure it is clear that this is 180 degree. That is theta p plus alpha plus r equals 180 degree, from which r equals 180 minus alpha minus theta p. You can put it in equation 3. Then you get 180 minus alpha minus theta p equals 90 minus theta p. Theta p minus theta p would go, then you get alpha equals 180 minus 90 or 90 degree. So the result is at Brewster's angle of incidence or at polarizing angle of incidence, the reflected light is 100% plane polarized, and that reflected light and refracted light are mutually perpendicular. That's the result. We will discuss the rest in next past. Thank you.